welcome. I don't know about you, I'm quite hyped because this is already a successful afternoon for me because a few hours earlier sitting in the Deutsche Bahn, I wasn't even sure if I would be here at all. So whatever happens now, it's already way above expectation from my side. But I hope we can make it interesting for you guys as well. I know it's sunny outside. There are a lot of issues at Republica that you can debate and become part of a discourse and learn and so on. Quantum most probably isn't the easiest of those. So we appreciate you guys being here. And we appreciate you guys forcing us to do this on English because it helps as many of the quantum science and technology and policy debates are happening in English anyway. I'm here with two distinguished co-panelists, and I'm very happy about that. We are all somehow connected to the Berlin quantum ecosystem. I will invite these fine gentlemen to say something about their role in a minute. I'm one of the co-directors of LEAP. LEAP is the startup, a knowledge transfer unit of Berlin Quantum. Those of you who know Berlin and have worked with Berlin will not be surprised that we are putting hard work and coming up with new brands and brands inside of brands. So LEAP is part of Berlin Quantum. Berlin Quantum is an initiative that has mainly been driven by the Senate as well as the Berlin University Alliance and also non-university science actors in Berlin. But you can forget all about that. Only address you need to keep in mind is LEAP. Should you be interested by anything you heard here today, reach out to us. Even more so if you believe that you can turn this into some kind of real-world impact with an idea or a network or a problem that you have. And with that, you're not going to learn anything about quantum technology and or science from my humble self today, but from these two guys. So maybe you can share a sentence each. I know, Markus, maybe you want to start. This is a very small stage compared to what you do in your free time. Huh?
Well, stages, sizes. We talk about quantum technologies, we talk about microcosm, so I think it fits perfectly. Yeah, welcome also from my side. I'm happy to be here. My name is Markus Krutzig. I'm a quantum researcher, no big surprise. I work at the Ferdinand Braun Institute in a joint research group with Humboldt University, and our work is about making quantum sensors practically usable. So we think about the quantum physics, but we also think about the engineering, the software development, maybe even about products when it comes about working with startups or enabling startups, because we believe in quantum technology or in quantum sensing. We are really looking at game-changing technologies, maybe something we will all use in the next, couple of years without even knowing it.
Well, that leaves me. So my name is Peter. I'm also a quantum physicist. I studied physics here in Berlin a long time ago, and I was very fascinated by the foundations of this rather weird part of science, and I went into the foundations of it and all the rest and kept on studying. And at some point I realized, after touring the world, that coming back here is a really good idea. So since 2 years or so, I'm back in Berlin from having spent time in various European and North American countries. And it's great to be here because now we can turn that fascination into something useful, and it's a great time to do that, and it would be a great time to discuss it today. And I guess Manu will ask us some questions. Maybe we'll have room for audience questions. I don't know.
I hope so, yeah. We'll make it on the fly. As one of the first things that I learned working with quantum scientists is that your observation changes anything anyway. So this panel also will only emerge once you guys are observing it, and that will be the hopefully only bad joke that I'm making today. Both gentlemen are quantum scientists. They are also very humble entrepreneurs, which is why they didn't put that into their introduction, but we will come back to how to turn scientific progress into real-world impact via entrepreneurship as well. But before we do that, who here has heard about quantum technology at all? Right.
Only that.
Partly. Keep your hands up if what you have heard is about quantum computing. Yeah, there you go. This is partly the reason why we have curated the panel the way we have, because this is a phenomenon that is observable all around society, in policy circles, in investor circles. I just came back from the second most important tech conference happening these days. Obviously, I will put it this way, the Tech in Heilbronn, which is organized by the Handelsblatt, and I've played the game that I play at every gathering these days, asking, have you heard about quantum technology? And then, does this equal quantum computing for you? And there were decision makers from policy, from economic, from journalism, who said yes. Well, what else could quantum technology be? And here we are, with two experts coming from quantum technology, not working on quantum computing. But I have to do this, guys. Would one of you do me the favor of giving that little lecture that you have given so often, I think, about why quantum technology is more, so to say, than quantum computing, and what else is out there?
I mean, we can try giving 2 lectures, right? No, my pitch is the following there. I mean, first of all, maybe I'm the wrong panelist at all, because every time I go home and try to explain my family what I do, I fail. And my mom calls me, "You're doing quantum computing." Dude, and I hang up the phone because it's actually wrong. I mean, it's clear, you know, we all work with computers, we understand better computers will help our lives, full stop. That's why the story about quantum computing is so good. But what we are doing, I mean, Peter doesn't like this when I say it, but I say the boring type of quantum technology, because our sensors are there. Yet they are sold, and you can buy them, and you can work with them, and you can improve our lives already. Whereas quantum computing has a lot of potential, I do not doubt this, but it's still some way to go. And rather saying, oh, this is, you know, the better approach towards quantum or not, I say I go with the musician way, and I say it's more like a chord of a guitar. You need to think all the applications of quantum together. With sensors, you get better data, you get more data, you get different data you probably haven't ever been able to sense. With computing, you can understand, you can model the data, you can optimize the data, you can work with this. And in the end, if you have to have an application where you need to securely transfer your data, then quantum key distribution comes into play. So I think it's a chord of all 3 applications.
Does that make sense to you guys? So at which point you're losing your mom?
Yeah.
You're saying the quantum sensing stuff is boring, by which you mean, I assume, it already works, right? It's not that exciting, maybe from a scientific perspective. But you said Peter wouldn't be 100% agreeing. So how's Professor Krüger's take on that?
Yeah, I don't agree that it's boring. I mean, I got into this foundations of quantum physics business because I thought it's so strange. I don't understand it. And people way older than myself started to try to understand the foundations of quantum physics and didn't believe the implications. Even the famous Einstein famously did not believe the full implications of quantum physics. So that was so fascinating that I tried to understand it, and other people did too. And there were many experiments. How does this all fit together? Is it really true? Is it really everything? And we've learned so much from these experiments, how to handle quantum systems, which are just behaving so very differently from the world that we experience every day. And then, yes, I was fascinated when I was a young student and starting my PhD that quantum computing could be actually an application of this. Suddenly it all made sense that you do all these experiments to understand foundations, you can do something useful with it. I thought that was amazing. You could solve problems that are too hard to solve for a normal computer, you could solve efficiently. I thought that was great. But then I went into studying that, into working on that, into helping building a quantum computer. And now this is about 20 years ago, 25 years ago, and I feel the real breakthrough just has not happened. And on the way, I discovered, as so many others did, that this taming of quantum systems, this knowing how to treat an atom or a photon, a particle of light in the lab, is just very useful if you stick with the very basics and you just use it to measure something, which maybe sounds boring, but to me is not boring at all, because it's really the difference of these kinds of objects from our everyday life that really allow us to suddenly, for example, in our case, measure magnetic fields 100 billion times smaller than that of the Earth.
And why would I like...
first, right?
Right. Why would I like to have that? I mean, I've been talking at that conference yesterday to people, and they told me we already have very cool sensors. And I saw in their eyes that they have no idea how much cooler this is.
Yeah, why would you have it? Because well, one thing is, when you're better than before in measuring something, you discover something new. That's always been the case, and that will always be the case. And the latest fascination for me personally was that you can measure what happens inside a human brain. We can measure the currents that flow in the brain between neurons to establish the function of the human brain and to understand it, but also to understand what's wrong in individual cases when people have diseases. And this requires, in order not to drill down a hole into the head and to measure something, this actually requires that level of sensitivity to what's going on there, and then you can measure it from the outside. You can sort of, at a distance, put some device near your head and it can measure what's going on inside. I think that's super fascinating. And yes, there are many other applications, we can talk about those, but this is one of the original fascinators that's motivating so much.
Let me build up on that, Peter, because you said there are many different applications. All of them somehow are summarized at what we see in the title as well, the second quantum revolution. Now, if I would be a scientist, that would give me a hint that there must have been a first quantum revolution. Am I onto something?
Manu, you may. So yeah, I mean, we were speaking about the second quantum revolution, and of course there was the first one. First thing home message would be, when we look towards these sensor developments we are doing, you can use terminology to distinguish between what is first, what is second, but in the end we want to improve an application. We want to build something which is better. So the terminology discussion is important from the scientific perspective, but I'm not doing that, that intense. Anyway, we are looking at the beginning of the 20th century, 1900 something, where experiments started to show results which couldn't be explained by, the theories which are at that time actually the ones who worked out. So people started to think about, why is this the case? And of course they came up with different interpretations which have been a hint towards how the macrocosm, so atoms, photons, the smallest world actually behaves in laws of physics. Yeah? And it was also Albert Einstein who interpreted experiments newly and differently in a way that kind of, and Max Planck who guided the way, there must be something going on there. Yeah? And these kind of beginning of the quantum age, you can determine to the beginning of the 20th century, you can say it started with 1925, speaking about the 100 years you're probably referring to. That all was a very exciting year where, our understanding of the microcosmos led to applications. And the first quantum revolution, using lasers, you all use cell phones, you all use computers, that was only possible because people understood what happened with the electrons. Yeah? How can I build transistors? How does MRT work? That is all something which we are all, maybe are using in our daily lives.
And Markus, I have witnessed you becoming a foodie while explaining this. Maybe you can share with the audience the distinction between first and second and the food picture that you have for that.
Manu always remembers the worst slides I put together, so I'm sorry for this. But anyway, the picture was a little bit like when you're cooking spaghetti and you take a lot of spaghetti with your spoon and put it on the table. That's kind of the first quantum revolution. So we know how to work with these spaghettis, but there are lots of them. And now in the second quantum revolution, we know how to actually take one single noodle and do very nice things with it. That's probably what you have been referring to.
Lovely. Finally, something that I understood. Now, the other part of the title is a mix of Berlin, Germany, and Europe. I would like to start with Germany. the most distinguished science policy advisory group published a few weeks ago a report on which fields and which disciplines and which technologies are of most importance to Germany and should be looked at by the federal government with, you know, the most love, so to say. And turns out quantum technology was, I don't know, number 1 or number 2, but very high up in that ranking. Do you guys feel that policy has understood, or policymakers have understood the importance of quantum technologies of all kind? Not just, you know, shiny computers, but also sensors that we could put in cars and on human brains. And do you feel seen, to put it in a more, you know, Berlin therapeutic speech?
Well, I think yes. I mean, it improved in a way that, I mean, there are very distinguished funding programs laid out by all of our different ministries. So what it turns out in the beginning to be maybe one or single call, now it's very diversified among different topics, yeah? Speaking about computing, sensing, and enabling technologies, and all these kind of, you know, cross disciplines. So I think they understood that it's not about one single topic, but what we're looking here, if we want to be successful, we need to go way beyond that single application. I just mentioned enabling technologies. So Berlin is pretty strong in the photonics sector, yeah, historically, and when you look at the companies and the research institutions. And actually, we need these photonics as an enabling technology for all quantum. Yeah? We need to have laser light. We didn't mention this. So when we talk about quantum applications, first of all, you have to have a quantum system. In our case, it's atoms, but it can be molecules, it can be something else. But everywhere, mostly everywhere, laser light is used as the tool to manipulate, to make the measurements. And it has been understood, to give the answer to your question, that this is a broad approach. Yeah? We need to think about enabling technologies. We need to think about software. First, you know, it was like PhD students running experiments in the lab, building their own code. Right now, we want to build a reproducible, scalable product, yeah. So we need different type of software, yeah, and it can't be some LabVIEW crash code which is just not working every second day. So I think policy understood this, and you know there are a lot of funding calls which exactly hit to this interdisciplinary approach, I would say.
And people like Peter wouldn't have come back to Germany if it wouldn't be the case, right? I mean, you could have stayed in UK and do your research and your entrepreneurial projects there.
Yes, so I do think that actually it's a mix of things, right? It's an ecosystem. It's not only politicians who don't really understand the underlying science and who might think that only one branch of the technology is what it's all about, and they might not understand the diversification, that there's also communication and sensing and not only computing. But yes, they do understand that this is an important opportunity, and they do understand that there's strength on this continent, and also specifically in this country, and hopefully specifically in this particular metropolitan region here. So I think that's good, but it's also attractive and perhaps something we can improve on, that we make it easy for people to come here. Many people don't think that science is as supported as it used to be in part of North America now. And we need to be attractive to people who may, you know, for decades we had brain drain from Europe to North America. Maybe it's time to reverse that. Maybe we have to bring up the courage and make this ecosystem here strong. We have an international background. We're speaking English here now, right? It is important that we utilize that. And of course, quantum physics actually was born in this very town, and it remains strong in spite of everything that happened in between. It's still an area of technological and scientific strength. And there are other European countries, and I think rather than thinking is the UK better, or Germany or France, or whichever other country, we need to work together. And Europe as a whole really has strength here, and I'd love to see barriers removed, also those that go beyond financial ones, for example, bureaucratic barriers, etc.
And Peter beautifully built this bridge, being a European cosmopolitan that he is, to Europe in this title. Also the European Commission, that would have been my next point, declared a few months ago quantum technologies to be one of the four core technology groups that we need for what is now discussed. And it has been discussed at Republica for many years now, and but this year very specifically, our technological sovereignty. They had to explain what that could mean. Why is quantum technology suddenly of such an interest? And people are talking about the global quantum race, which normally also is about computing, right? But when you say China versus America, North America, USA, that's normally the global quantum race. But the Commission specifically said this is about all quantum technologies. We need all of them for our technological sovereignty. What could go wrong if we don't, build these ecosystems in Europe?
I mean, the most direct example is, of course, data security. I mean, when you look into how you want to handle your data, you want to make sure you can handle your data safely for the next years to come. Yeah? So looking into potential technologies which may be a threat to this, or technologies which may be a solution, because if you do your encryption based on the laws of quantum physics, you have to have somebody who can, undergo these laws to actually look at the data. Or in other words, we have measurable security when you, transmit your data via quantum channels, that's so to say, in a way. When it comes to sensors and measuring physical properties with higher resolution, of course, there's a lot about navigation. There's a lot about how your next deep technology applications like navigational points when you come to GNSS. That's all something which belongs to our daily lives. Probably many of these people here came in by just using app application of their choice by just looking, where is my little dot showing me where I am? And this is based on global navigation satellite system using quantum technology of the first generation. So it's rather be good to look at something which is, the next upcoming generation to just be ready for this. We all want to be free to navigate wherever we want, and we need our tools. No? These are two examples.
Yeah, I mean, we see in the political landscape of the planet today that things can change very quickly and that old dependencies might become dangerous. So while I'm fully for global cooperation in developing new technology, I do see, maybe for the first time in these years now, that it actually is dangerous to have too much dependency. And this can be, it can be in global positioning system, but it can be also in. Another example that I like is in our attempts to help with mitigating the impact of climate change, where we work on electrification of transport. We need energy storage, in particular batteries for that. And the battery production that we have in Europe is too expensive, and just the yield is too low as compared to the Far East in this case. And if we could do better then, and we can have our own European production, we'd be better off, we'd be less dependent, and it would be helpful for us to do that. And we're developing technology to help with that, again, based on quantum technology. So I think these are very different examples, but there are many, and there are probably many more.
But the one you gave helps me beautifully, again, in using it as a bridge. Because let's stay with the example of renewable and energy autarky and batteries. Right, or efficiency in the energy system. Now, both of you have done a lot of research, are successful researchers, and you could stay in that career path without doing anything else for the rest of your life. But both of you have decided to try to gain real-world impact with your research, and both of you have decided that there are better ways than just sitting on knowledge, putting that knowledge into a patent and then selling it to someone. So what has been your motivation in making spin-offs out of this? So what turned you into sciencepreneurs, to stay with the Berlin Mitte way of thinking and talking about this?
Well, for me, it kind of maybe was always in my heart and in my mind, because I started to work with quantum sensors ever I studied physics in a way. And when you work with these type of technologies, as we said and discussed today, there's an application side, and it's very close by. You have to think always the application with what you're doing. It can be very fundamental, but there's always application driven. So I was fascinated by what can you do with this? How can you help society? How does industry maybe improve the business model on using quantum technologies? And then I fell in love also by talking to fellows like you to look into, okay, what are the visions? Where can you put this in? Where are the people you talk to actually make this an impact beyond the scientific nurture I every day eat when I talk to our students in the research lab? And we all maybe know big administrations like universities and so on. They are very helpful. I like them a lot, but there's ways you can do things faster. Yeah? And just to jump on the fast track to see, okay, here's something I was telling our funding agencies in the, sorry, I do not know the English word in Deutsch, Verwertungsplan. Every time we write a project, we say why this is useful, and they say that's useful, here's the funding money. Now I want to prove this. That's the ultimate test, and that's why I'm fascinated to jump on this side. And it definitely is not actually a different side. We have to think this all together, and I think to be really successful, it's kind of, yet again, a ping-pong system between science and entrepreneurship.
Right. Peter.
Yeah, I mean, I can just echo that. It's just so much fun to actually work on something that will be in people's hands. And this is just not what universities do, or in my case, I work for the federal government. I just don't think those places can do it. They cannot come up with a product. They're actually not meant to. It would be about commercial interests and so on. But I just think the liberty of setting up your own shop and just building something that people can use is just such a strong driver that I can't help, and it's just what I want to do.
And now, being stuck in linear time, I'm afraid we do a hard cut because there was someone already signaling us that we are getting close. I hope there are some takeaways for you. This is fancy stuff, right? This is close to magic, but as we have heard already in literature decades ago, all technology that is highly advanced looks like magic. So you need to talk to the magicians to get an understanding of how this could impact you, your industry, your ecosystem, your research, your city. That's what we are for. So if you, again, are interested in any kind of follow-up, come talk to us. If you want to invest in these fine gentlemen's companies, come and talk to them. And with that, I think we touched literally everything that we could have touched on and finished nothing of that, which is always a good panel, in my opinion. So thank you guys for coming. Thank you guys for coming and staying, and enjoy the rest of Republica.